I'm NBC 15 Chief Meteorologist Alan Sealls talking about thunderstorms, and not just ordinary thunderstorms, thunderstorms that grow more powerful and become severe thunderstorms. Be aware of severe weather. Now, when you talk about severe weather, people envision lightning. Well, lightning comes from all thunderstorms, so lightning doesn't make a thunderstorm severe, and neither does heavy rain and gusty wind if the wind is not extreme. Even if you're out shopping and you see a shopping cart going by pretty quickly, doesn't mean it's a severe thunderstorm. And clouds like these also do not say for sure that this is a severe thunderstorm. Those are mammatus clouds, and they come with severe thunderstorms and regular thunderstorms. This is one that will capture your attention too. It's called a gust front, and these are pretty common when a thunderstorm is slowly moving into a mass of warm, humid air. But it's also called a shelf cloud, and it's as simple as the cold air rushing out from a thunderstorm from underneath and the warm air rising up above it, and it creates the edge of the cloud looking like a shelf. It's not a severe thunderstorm. There are lots of things that we see and experience where we feel that a storm is severe, but it's all about the technical criteria. And the criteria is wind that's over 57 miles an hour, straight line wind, or hail that's over an inch in diameter, or a tornado. Any one of these by itself creates a severe thunderstorm. And of course, you can have them in combinations. But when you think about severe weather, just look at this preliminary data from 2021 from NOAA, and these are reports of severe weather. Over 13,000 reports of winds over 57 miles an hour. Now compare that to tornadoes, 1,400. These numbers are pretty typical in an average year, but what it shows you is most severe weather is straight line wind. And it shows you that it takes a lot to get a tornado. Now, here's what's really interesting about that 1,400 tornadoes. How many of those would you imagine killed people? Not that many. It was only about 13. And here's the problem with tornadoes. The overwhelming majority of tornadoes are weak, they are brief, they are small. EF0, EF1. They don't do substantial damage. Now, once you get to EF2 and EF3, those, of course, are much stronger. And it's the EF3s and 4s, especially in 2021, that were responsible for the most number of deaths. It's rare to get EF5s, but they do happen. And it's something that, of course, can be beyond deadly, beyond devastating. Also consider this, when you talk about tornadoes, these are based on damage. So if a tornado moves over an open field, there's very little damage. But if it moves across a subdivision that used to be an open field, you get tremendous damage. And that's all about population growth. That's why the numbers go up. Look at this video. Was that a tornado? Well, unless you saw it happening, you can't say for sure just looking at the video. We know it is wind damage. We know that was a mobile home. Those are very vulnerable to severe weather. But just looking at a single image doesn't tell you if the winds were rotating or straight. When it comes to severe weather, days in advance, you hear of a weather outlook. You also hear a forecast, and then eventually you hear watch and warning. So you need to know exactly what these four things mean. An outlook by itself is a broad picture of what's going on. It happens when you're far out in the distance. Think of it like playing golf. If you play golf when you're driving, you have a hard time hitting the target because you're far away. When you're pitching or getting closer to the pin, you might chip it and pop it up and get close. And when you're putting, if you're lucky, you'll get it into the hole. But this is the same analogy for forecasting weather. The farther out you are, it's an outlook. You get a little closer. It's a forecast. Even closer, you're watching because you're watching to see if you're going to get it in. And if you're right up there, you get a warning. You get it in, which is a positive thing in golf. Not so positive in severe weather. Now, severe weather doesn't just pop up out of nowhere. Even though you can get an isolated severe thunderstorm, there are certain patterns that meteorologists will look for to know well in advance that you could have severe weather. And this is one of those typical patterns when you have low pressure with a cold front trailing to the south, cold air on one side of the front, warm air on the other side. Oftentimes people will oversimplify how this happens. They'll say warm air meets cold air, you get tornadoes. It's not that simple. But once you have this set up, then you need a strong wind in the upper atmosphere crossing that lower wind at an angle. And that's a wind that we call wind shear. This is why you don't see many tornadoes in the middle of summer. You don't have that strong wind in the upper atmosphere. It's why you don't see many tornadoes in winter. You don't have the humid, warm air in the lower atmosphere. So these are just some of the ingredients, but that's just a small part of it. We know that anywhere in the United States, when it's warm and humid and windy, strong south wind, you might start thinking severe weather. But that's where we are, right here at the ground. You have to think about what's going on above your head. Above your head, the ingredients to get severe weather is above that warm, humid air, you need some cool, humid air, and then you need air to dry out rapidly above it, and then the temperature to fall above that. So just consider the atmosphere is way more than 4 layers, but this is the complexity combined with wind shear to determine if you'll get severe weather, whether it's more likely to be a straight line wind event or a tornado event or a hail event. Many different variables. So the outlook that I mentioned, that's something that happens in the terms of severe weather. Those are issued 3, 4, 5, 6, up to 8 days in advance when computer models project that a certain scenario may develop in a spot, and when, of course, our mental database as forecasters tells us that it's possible. What's key to know, when you talk about outlooks for severe weather, there are only 2 options, possible or likely. So 3, 4, 5 days out, there's no detail, simply because you're too far away to see the detail. Once you're within 2 or 3 days, then you start to see that 5-level scale that goes from marginal to high. And the higher that number is, or the brighter the color is, it tells you the more likely that you're going to see severe weather within that area. Also critical to know that there are boundaries there, and you can zoom in on your weather app and see whether you're on one side of the boundary or the other. Weather doesn't work that way. Weather is not digital, it is analog, and these are just rough estimations of where things are most likely to occur. So those 5 levels that I talked about, level 1 out of 5, that's a marginal risk of severe thunderstorms. It means isolated severe thunderstorms are possible. That's the key word, possible. Doesn't mean they're going to happen for sure. It means you need to stay updated to the forecast, and marginal risks are pretty common, pretty routine. A slight risk of severe thunderstorms, that's a level 2 out of 5. And now you're talking about scattered severe thunderstorms. So more in the way of thunderstorms and also the possibility of a tornado. But even with a slight risk, there's no guarantee that you're going to see severe weather. Once you move to level 3 enhanced risk, then you really have to be alert, because it means multiple severe thunderstorms and multiple tornadoes become more possible. And even at level 4, which is a moderate risk, now we talk about likely. So these are the ones where you know pretty well that the next day or two there will be powerful thunderstorms and there will be tornadoes, not just brief, short ones, but ones that will stay on the ground for a long period. Moderate risk, level 4 out of 5. The one you don't want to deal with, that is a level 5 out of 5, and that's a high risk where tornadoes are almost certain. But the problem is you don't know where. You know within a certain area those ingredients are coming together. And these are scenarios we see every few years, fortunately not too frequently, but back in 2011, from Mississippi into Alabama, Tennessee, and Georgia, that was a major outbreak of tornadoes, some of which stayed on the ground for well over 50 miles. They were EF4s, they were EF5s. It was hundreds of people lost their lives. This was a weather scenario where meteorologists knew days in advance that it was likely. Quick true or false question for you. Tornadoes can move at up to 60 miles an hour. It's true. Now, a tornado, especially in the summertime, may move very slowly. It can move 5, 10 miles an hour. But in the springtime, based on the jet stream, which steers the thunderstorms, you can have tornadoes moving on the ground at 60 miles per hour. And this video is sort of a classic tornado. It's what people expect to see. A smooth funnel stretching down from the cloud and then debris and spray around the bottom of it. But most tornadoes are not as photogenic, if you want to use that word, as this one. Many of them are wrapped with rain, and in many parts of the country, those clouds are so low that you're not going to see it from a distance. So what a tornado simply is, spitting air that is lifting things into the sky. So what it's lifting will create the color that you see. Another true or false, I halfway answered this. Tornadoes can happen in any season. The answer is true, but they are most likely in the springtime, and that's when the ingredients come together most often across the United States. And depending upon what part of the United States you live in, you'll see them also in the fall. You can see them in the winter, and you can see them in the summer. But here's something interesting. I showed you that 1,400 tornadoes in 2021. The question you may be wondering is, are we seeing more tornadoes? The answer is yes, we are seeing more. It doesn't mean that there are more, but we have cameras. We've got cameras all over the place. Everyone has a camera in their hand, and the population has grown. So now to see a tornado on a web camera is not unusual. And the more the population grows, the more reports of tornadoes we will get. So let's go back to the basics of watch versus warning. When it comes to a weather watch, whether it's a tornado watch, a severe thunderstorm watch, it means that the hazard is possible. The ingredients are in place. And the watch is typically issued in terms of severe weather. It's issued and it will last 6 to 8 hours, and it covers a large area. And we're talking tens of thousands of square miles, multiple counties. This is just for example. And this is a regular, say for example, tornado watch. There is something called a PDS, particularly dangerous situation. So in a PDS watch, it means the risk of a tornado is a lot higher than you would see in a typical tornado watch. Now, if there's a tornado warning, the tornado warning is issued in a smaller area, which could be dozens of square miles, or it could be hundreds of square miles, typically a part of a county or several counties. And a tornado warning or severe thunderstorm warning lasts anywhere from 30 to 60 minutes. And again, it's a relatively small area. It means a tornado is imminent or it is happening. And within this tornado polygon, it's a multi-sided box, think about this. Tornado is very small. Even the largest ones are a mile wide. So if there were a tornado right in the center of that box, the majority of the area would not feel the impact. But the box spreads out because it is not totally certain where that tornado is going to go. What's also not certain is whether the thunderstorm creating it may cause it to lift, fade away, and then another one drops down in a different location. Everyone knows the basics of tornado safety. It's about getting into a small room, interior room of your home. Think of it as a football. If you are the quarterback, you want 2 or 3 defensive lines, even though you get one. But that's why you want to be in the middle of your home. You'll have multiple walls between you and the outside. And even though the outside walls may be blown in or fall, the inside walls, because the rooms are smaller, typically create a stronger structure. So bathrooms without windows, bathtub that does not have glass sliding doors, those are some of the safer spots within a home. In tornadoes, they strike fear because when you hear about them, it's typically after a big event or a big tornado like this one in Tennessee, where homes are destroyed and unfortunately people lose lives. But it's all about being prepared, knowing where in your home to go. And if you are building a home or refurbishing a home, consider building a safe room, a reinforced room for your home for both tornadoes or hurricanes or any other high wind. There is another phrase that you'll hear every once in a while, just like you'll hear tornado warning or flash flood warning. You'll hear tornado emergency or flash flood emergency. And what that means is this is certain, this is deadly, you've got to do everything you can do in your power to protect yourself. And by the way, I did talk about flash floods, and that's because you can get flash floods without a severe thunderstorm. And you can get a severe thunderstorm without flash flood. So technically they're 2 different things. But you do need to have one of these for your home. This is a weather radio, and it gets direct broadcast from the National Weather Service 24 hours a day, 7 days a week, and it has an alert to let you know when the bad weather is coming and where it is. This is also a weather radio. It's called an all hazards weather radio. This one has a solar charger, it has a flashlight, it has a hand crank in case you lose electricity, so you can crank it up. It also has a USB port to charge your devices. So those are tools you need to be safe, along with your cell phone and a weather app on your cell phone to let you know when you may deal with the threat of a tornado or any other sort of weather emergency. So on your cell phone, I know many folks in the middle of the night, you hear that alarm go off because it's a tornado warning, and then you look and find out that it's not your county. Well, here's one of the reasons why. This is a fictional county, the gray box. It's called Allen County. The city of Allen is right there in the middle. But cell phones pick up signals from cell phone towers. And cell phone towers, if they're on the edge of a polygon for a tornado warning, the signal will go outside of the polygon. And that will, unfortunately, alert you to something that's not in your area. If you're on Wi-Fi, and of course for your weather app, make sure your weather app is set to alert you for where you are. Here's another way to look at weather outlooks, watches, and warnings. An outlook, as I mentioned, think of it as growing tomatoes. A tomato outlook is when you have all the ingredients, but you really haven't put them in place. The outlook is, oh, I'm going to have a tomato later this year. If you plant your seeds, water them, give them sunlight, you literally watch day after day, week after week, and eventually you'll see a little bud. And then finally, if all goes well, you'll get a tomato, if the critters don't get it first. So that's sort of like a severe weather outlook, a tornado watch, and a tornado warning. It goes from having the ingredients, putting the ingredients together and watching, and then you see whether you actually get something or not. So I mentioned in severe weather, hail is also a criteria. Hail that's over an inch in diameter is what will create a severe thunderstorm by definition. Bad for your vehicle, bad for your roof. This is a research vehicle, and that vehicle, of course, encountered some hail. And by the way, when you're driving, even tiny hail, it sounds really big if you're driving into it and hits your vehicle and hits the roof. You know that hail comes from thunderstorms, and regular thunderstorms create small hail because the temperature at the top is much colder than it is at the bottom. It's actually below freezing. In a thunderstorm, you have air that rises, warm air that goes up high. When it goes up high, any liquid may freeze, and that liquid creates ice. And the air that goes up helps to juggle the ice. Sometimes the ice will circulate way up above the ground. And as long as you have a strong updraft, that hail will stay above the ground. But as soon as something stops that updraft, whether it's another wind gust coming from a different direction, or the fact that the thunderstorm is just fading and weakening, all that hail comes down to the ground. So you heard the cliche, what goes up must come down. That's what happens with hail. And when it comes down, if you stop and think about it, all the air and rain that went up, the moisture that went up, it comes back down, and it drags air down to the ground quickly. And that's why it's really important to kind of correlate the size of the hail versus the wind that creates that size hail. So once you get hail that's an inch in diameter, about the size of a quarter, again, that makes it a severe thunderstorm. Some parts of the country will get much larger hail than other parts of the country, but when you start getting large hail, this is what you have to think about from a thunderstorm. It takes a wind of 50 miles an hour going straight up to create hail that's 1 inch in diameter. So when all that hail comes down, the wind that comes down, 50 miles an hour. So look at hail that's about the size of a tennis ball. It takes an updraft, a straight wind going up at 75 miles an hour to create it. So when that hail comes down, you have to start thinking wind gusting to 75 miles an hour. And once you get to softball size, you're looking at potentially winds of 100 miles an hour, maybe even more. And from severe thunderstorms, from straight line wind, there have been winds reported over 100 miles an hour. So what that tells you is people focus on tornado threats, but a EF0 and EF1 tornado may not be as powerful as a straight line wind that comes down from a thunderstorm and spreads out. That's called a downburst or a microburst. When thunderstorms move as a group, that's called a squall line. Simply just says they're all moving basically the same speed as a line. And when you're in front of a squall line, you can't avoid it. Squall lines don't have to be severe thunderstorms, but they could be severe thunderstorms. Let's talk about the science of trying to figure that out. In the distance, that is a tornado, and in the foreground, that's a storm research vehicle, National Severe Storms Laboratory. Meteorologists, we don't fully know what's going on in here. We don't know exactly why these happen. So we still go out and try to measure, using portable radars, for example, what's going on to help us better predict. We send up weather balloons, we use satellite, we use radar. And think about radar, which you see used on television often. A radar is an antenna. It sends out a signal. The signal comes back to it. And depending on how much of that signal comes back to the radar, it tells you how much rain is in the cloud, in the thunderstorm. But the problem, the shortcoming of radar, is it's not just looking straight across, it's looking upward at an angle. So think about that, it's looking upward. And as it does so, you will hear the phrase dual pole or dual polarity radar. And what that is the radar can send a signal, a horizontal signal, or in this case vertical, or a horizontal signal, and it can measure in 3 dimensions what the shape of that object is. So we can tell the difference between a raindrop, a hailstone, a piece of fiberglass that was lifted by a tornado. So radar can do that, and obviously, of course, with Doppler radar, it can tell whether the rain is moving away from the radar or toward the radar. So all of that allows that instrument to look inside the thunderstorm to see if the air is rotating, to see what it is. But here's the big problem. Tornadoes happen down there. So the radar can rarely see what's going on close to the ground. It sees what's above the ground. And that's one of the most difficult parts for a meteorologist to predict exactly what's happening when you look at a radar like this and you see that circulation signature, a counterclockwise signature of, in that case, that's a tornado. A meteorologist knows that. But when you really try to study the colors and figure out what's going on, it's way more complex than just glancing at the radar and saying, oh, there's a tornado there. So forecasting severe weather, it's not a simple task, and that's why there's a lot of uncertainty. This thunderstorm, beautiful cumulonimbus cloud, if you're not underneath it, it's not necessarily a severe thunderstorm. But when you study how different parts of it grow, different parts fade, wind comes out, wind goes in, and how it interacts with other thunderstorms, all of that plays into trying to predict whether it's going to become powerful and whether it might produce an isolated tornado. I'll leave you with this, and this is important to figure out. In the distance, just pretend that that's 8 days away, that that's a threat of severe weather. And as you get to 7 days and 6 days and 5 days away, you still can't really figure out what that is. Just like if you're driving down the interstate. You can see if there's a vehicle in the distance, but you don't know if it's stopped, if it's in your lane, the other lane, if it's going to exit. You don't know if it's a police car. You don't know if there's a truck behind it. So when you forecast weather, the farther away something is from you, the much harder it is to figure out what it is. Stay updated to severe weather. Make sure you have a safety plan. I'm NBC 15 Chief Meteorologist Alan Sealls.